Another important concept that I think every Revit beginner need to understand is reference planes and work planes. Since Revit is a 3D software, work plane and reference plane gives objects and geometry a datum point. Hi, I'm Pisan. If you are a student or an architect who is looking to learn or have a better understanding of how to use Revit, I hope that you find this video helpful. Let's get started. So, work plane and reference planes as related to geometry. What you're seeing here on the screen are three simple geometry 1, 2, and 3, and three work planes, level 1, level 2, and sample reference plane. First, let us begin by talking about what is work planes and why we need them. Since Revit is a three-dimensional software, every object, including doors, windows, walls, furnitures, etc., needs an X, Y, and Z coordinate. Because Revit needs to know where we want these objects to exist in this three-dimensional space. Since our current view is an elevation view, all of the reference planes are spanning from left to right, which is an X-axis. And all of the geometries starts from the bottom of the screen and projects toward the top of the screen, which is the Z-axis. Now let's take a look at how geometry responds to work plane. On the screen I have geometry 1 activated and then selected. Okay, so on the left hand side under properties, the properties here is the property of the selected geometry. Right now this geometry work plane is set to level 1. And the extrusion start, which is the bottom, is set to 0. So the 0 feet and 0 inches you're seeing here is the distance as related to level 1, which is the set work plane. Now the extrusion end. The extrusion end is set to 12 feet, which is the 12 feet as related to level 1 as well. So that means this geometry will have the total height of 12 feet. Now let's see if we change those values. We're going to start with extrusion start. Okay, so if I change this value to a positive number, let's say positive 4 feet, the bottom of the geometry now will be 4 feet above level 1, which is the set work plane. And since the extrusion end is still referring to the set work plane, which is level 1, once I click the apply, the total height of this geometry will be 12 minus 4 feet, which is 8 feet. Hopefully now you can begin to understand how geometries work with reference planes. Now let's take the same object and apply negative value to it. So from the extrusion start, if I just add negative value in front of the 4, now the extrusion start will move toward the negative direction, which is toward the bottom of level 1, which is the set work plane again. And since the extrusion end is still referencing level 1, the total height now will be 12 feet plus additional 4 feet, which is the 16 feet. Now let's approach this a little bit differently this time. I'm just going to finish all of this and then shift our focus toward geometry number 3. So I'm going to activate this geometry by clicking on Edit in Place. Now we have geometry number 3 activated. Select the geometry number 3, and now the properties on the left hand side is the property of geometry number 3. So you see that the same values is applied to geometry number 3 as it was applied to geometry number 1. What if we want to change the work plane? We no longer want this geometry to start from level 1. All we have to do is click on Edit Work Plane, and then you see this dialog box. Under Specify a new work plane, under Name, if you change it from level 1 to level 2, behind the dialog box, you see that level 2 is highlighted. After I click OK, geometry number 3 will still be 12 feet in height, but it will shift up. But all of the value extrusion start and extrusion end will now be referencing level 2 instead of level 1. As far as everything else, it will still work the same. Geometry number 3 now is using level 2 as the work plane. If I want this geometry to be total of 4 feet in height and be offsetted 2 feet from the work plane, all I have to do is select the geometry, and now the property here on the left is the property of the selected geometry. Now, the extrusion start, I want to offset it 2 feet from level 2, so I just have to enter 2 feet. And since I want the total height to be 4 feet, I just have to set this extrusion end to 6 feet because 6 minus 2 equal to 4. Now let's take a look at how it works. I'm going to pull some dimension. That is extrusion end. That is extrusion start. And the total height of the geometry is equal to extrusion end minus extrusion start. Now, what happens if we change the extrusion start to a negative value? So when that happens, the extrusion start will be below the work plane. Say we want to offset the extrusion start to 3 feet below the work plane. We just have to add that negative 3. And we're going to leave the extrusion end at 6 feet. And now the total height of the geometry will be 6 feet plus additional 3, which is 9 feet. Like so. What happens now if you don't want to use any of the levels as your work plane and you just want your work plane to be somewhere arbitrary? In this case, you can use reference planes, and you can set your reference planes anywhere. It can be horizontal, it can be vertical, it can even have an angle to it. Now let's use geometry number 2 as an example. Select geometry number 2 and edit in place. I'm going to change work plane for geometry number 2 to the sample reference plane. Geometry number 2 now is referencing sample reference plane. If I select on the geometry, now the property on the left hand side is the property of the selected geometry. As you can see again, the values assigned to this geometry is the same as the previous 2 geometries. For clarity, let me widen the property palette a little bit. You can see now that the work plane is sample reference plane for geometry number 2. Now let me precisely place sample reference plane. So I'm going to get out of this editing mode. And I'm going to use dimension to help me precisely place the reference plane. So I want it to be halfway between level 1 and level 2. So I'm going to equalize this. And that should make it 5 feet. Now we can go back to geometry number 2, edit in place. Say if I want geometry number 2 to have the starting point of the extrusion and the end point be at the same location at geometry number 3. What I have to do here is I have to set the extrusion start to have a positive offset of 2 feet. And the extrusion end to have the positive value of 11 feet. So if you take 11 minus 2, that gives us 9 feet, which is the height of geometry number 3. And that's what we want geometry number 2 to be. So I'm going to apply. And then you see that it is levitating in space at the same height as geometry number 3 to verify. Now as a comparison, let's start building a new geometry from scratch. So I'm gonna OK out of this and then add another reference plane. So RP on my keyboard. I'm going to add a reference plane somewhere around here. And say I want this reference plane to be 3 feet above level 1. So I'm going to use dimension to help me locate that. And notice that this reference plane does not have any name. So I'm going to name it so that later on we can find it easily on the list. Let's call it sample RP2. Now from the top view, I'm going to build a geometry from scratch. So I'm going to be in level 1. And since this new reference plane is above level 1 and below level 2, I'm going to be in level 1. This is geometry number 2. I'm going to build another geometry at 12 feet in height and right next to geometry number 2. So architecture, the bottom half of the component, model in place. I'm going to categorize this as generic models. And then I am just going to accept the default name. I will use simple extrusion and then sketch line. And since I want this new geometry to reference off of the new reference plane that we have just drew earlier, I'm going to set the work plane at sample RP2. The starting point will be 0 from sample RP2 and the end point will be at 12 feet at sample RP2. So if I OK out of it, and then confirm that we're done with this geometry, then we can go back to south elevation. You will see now that that is the new geometry with 0 feet from the new reference plane and 12 feet in height. Let's verify. By now, hopefully you can see that work plane in elevation view can be levels or reference plane. Now let's shift our focus toward the floor plan. And I'm going to get rid of these 4 geometry and start fresh. Let me place a few column grids. And a few more reference planes. I'm going to call this vertical and call this one horizontal. Now I want to create a new geometry using reference planes that can be seen on plan view. On the first example, I will use grid line number 1 as the work plane. Now, if I want this new geometry to project toward the left side of grid line 1, the projection value needs to be a positive number. And if I want the projection to be toward the right side of grid line 1, then the projection value needs to be a negative number. Since we're going to be using grid line 1 as the work plane, we need to be either on the left or on the right side of grid line number 1, or east or west elevation. In this case, we're going to be on the east elevation. What you see here, these are 2 reference planes that we saw earlier on south elevation, and this is the horizontal reference that we have just added a minute ago. Now I want this new geometry to be a 4 feet by 4 feet, just like the previous 4. And this time it is asking me to select the work plane from the get-go. So I'm going to check on name. And earlier I said I wanted to use grid line 1. So that's what I'm using here. Grid 1. And OK out of it. And I want this geometry to exist between level 1 and level 2. So I'm going to place this geometry right here. So 4, 4, 4, and 4 again. Now if we confirm that we're done with this geometry and go back to the top view, we will see that this geometry will have a starting point on grid line 1 and the projection of 12 feet will be toward the left side of grid line 1. Now, if for some reason you didn't get prompted to select the work plane or you forgot to select the work plane when you created the geometry, you don't have to panic because as long as the work plane that you want to use is along the same direction as the current or the assigned reference planes, you can change it afterward. This generic model number 1 is referencing grid line 1 right now. But if for some reason we want to change this to grid line 2, all we have to do is select on the geometry, edit in place, select the geometry again, and then change the work plane from grid line 1 to grid line 2. Now, everything will look the same except that this geometry will shift to the right and align with grid line 2 instead. As far as offsetting, if for some reason you need this work plane to have an offset toward the left of grid line 2, you just have to set the extrusion start, say 2 feet. Then after you hit apply, the starting point will be offsetted from grid line 2 at 2 feet. Or if you want the total width of this geometry to be a little bit less than what you have now, which is 10 feet, you can set the extrusion end. Let's say if you want the width to be 8 feet, you just have to take the value here at extrusion start plus 8 feet, which is the width that we want, and that will give us the value for the extrusion end. Apply. To verify, that's extrusion start, that is extrusion end, and this is the width of the extrusion. Here comes the unusual part. So far, if you want the projection of the geometry to be toward the left side of the work plane, you have to set it to a positive value. And if you want the extrusion start to be toward the right side of the work plane, you have to set the value to a negative number. Now, if you change the work plane from grid line to a reference plane, the opposite is true, and I really don't have any explanation for that, except that's just how it is. But I'm not too concerned about that because if the projection didn't go toward the size that I want, all I have to do is to switch from negative to positive or positive back to negative. Let's have a look. I'm going to change the work plane from grid line 2 to vertical. The width of the geometry remains the same, except now that the positive value in the properties palette makes the geometry project toward the right side of the plane instead of the left side. To show you that, we're going to be making this current geometry project to the left side of the work plane, which is the vertical, instead of to the right. So we're going to be adding negative value to the extrusion start and extrusion end. Now, if you are planning on using grid line A, B, or horizontal reference plane as your work plane, you would need to be on the north elevation or on the south elevation to create the outline of your extrusion. If you want the extrusion to project toward north, which is the top of the screen, then you will need to enter a positive value on your extrusion and end. If the opposite, you want your extrusion to project toward the south, which is toward the bottom of the screen, then you will need to enter a negative value into your extrusion start and end. Before I end this video, there's one more type of work plane that I need to show you. If I have an existing object on the screen and I want to use one of the surface as a work plane, I can do that by creating an extrusion and then set work plane. And then here under pick a plane, you can pick a surface of the wall, surface of the roof, surface of the window, or simply just pick a surface of an existing geometry. So I'm going to select that, pick a plane, and OK out of it. I could pick this plane here, but then I would need to be on the north elevation in order to create the outline of my geometry. Or I can pick this one, but then I need to be on the south elevation in order to create the outline of my new geometry. Here I need to be on the west. You get the idea. Now, if I want to pick this top surface here as a work plane, then I need to be on the elevation view. It doesn't matter which elevation view I'm on. So say I want to use this surface here that you see on the screen as a work plane, then I just pick one of the elevation. In this case, I select south, and now I just have to go to set work plane, pick plane, OK, and then I can pick that top surface that we just saw earlier as my work plane. And again, I can pick the bottom, or I can pick one on the left, or I can pick the one on the right. In summary, we can use column grids and level as work plane. Column grids are used as a horizontal references, and levels are used as vertical references, while reference planes can be used in any direction and any angle. Hopefully by now you have a better understanding of what are work planes and references and what they're used for. Finally, I hope that you find the content of this video helpful, and hopefully see you again soon in the next video.